Everyone, hope you're doing well. Anyone do anything fun over the weekend?
Well, I'm out here in Kona, Hawaii. They had the Ironman World Championships going
Oh,
on Saturday, so that was super fun.
that's awesome. Did you watch it or did you like participate?
I've participated in past years, so we just watched it this year. Yeah.
Cool. That's awesome. That's super cool. All right. I believe we're waiting on a couple people, but we'll go ahead and get started in just a second here. Okay, let me send you guys a starter project while we're waiting, and you can go ahead and get that ready. All it has is a storyboard and an empty project, or I mean, the project is empty except for the storyboard, but we'll work off that just so we don't have to spend the time working on that on the UI, and we can focus on core data. And then
Hey Spencer, I don't think Mark or Brian or I have been moved over to iOS 10. Could you send us the project in like a message?
oh, yes. Yes. Definitely. Thank you for making that DM easy for me. All right, there you go. Okay, cool. So let's go ahead and get started here. We're actually going to start off with some of my amazing drawing skills. Just kidding, they're not amazing, but we're going to start off with some drawing. So just pull up a couple apps here so I can get this running. And we'll go ahead and get started here. Okay, cool. So we're going to talk about core data today. So before we dive into the code, I want to look at the documentation real quick. I want to go through some drawings, and we'll kind of understand what core data is before we try to use it. So getting a little bit of a backstory, I think, for anything can be nice, but especially when we're diving into a brand new framework like we are today. So let's pull up core data. Oops. There we go. Okay, so it says persist or cache data and support undo on a single device. So it is for saving applications' permanent data for offline use. You can also cache temporary data and add undo functionality to your app on a single device. Now, kind of a key thing here is saying we can save data on a single device. What this means is this is a form of what you would call local persistence, or in other words, it's actually stored like on your phone's hard drive. It's actually, like you save a file to your computer's hard drive, it's on there, right? Unlike if you store on like the iCloud drive, then it's accessible from anywhere. It's very specific to just the device itself. So even if I've got one app running on my iPhone and one app running and the same app running on my iPad, they don't share that storage, and that's something you need to be aware of. That's not necessarily a bad thing, but just something that you need to be aware of. And later on Wednesday, we'll be talking about how you can sort of synchronize, that together between multiple devices using basically, a REST API or a backend to store all of that information sort of externally as well. So something key here is we want to, generally the biggest reason that you use core data is right here, to save your application's permanent data. So what it means by permanent data is sort of things that the user creates, or some information that you don't want to fetch again. So as an example, if you make a journaling app, the journaling app isn't probably very good if it doesn't actually save the journal entry, after you hit save button and then close the app and you open it again, it's not there, right? That would be a pretty bad user experience if they go through the process of writing this whole journal entry out, and then when they open the app again, it's not actually there, right? So we want to kind of keep things around permanently. Now, I kind of want to talk about this permanent data here as opposed to something like we've used user defaults, right? So if we look at this, this is a somewhat different use case than user defaults. So yeah, so really what you should be using user defaults for is like this, where it says it allows an app to customize its behavior to match a user's preferences. So it's literally meant to store a user's defaults for an app. So if they like a dark or a light theme, if they prefer a certain font size, or they prefer some, speed at which the app runs, something like that. So settings, more or less. The thing with user defaults is it's not very good at storing large amounts of data. It's not really made for that because it's really just kind of like a dictionary, and that's really all it is. It's just, you store key value pairs like a dictionary, and that's about it. Whereas core data is very much built to handle very large amounts of data. You could literally store millions of instances of a model object, and it would be able to you would be able to interact with them very efficiently. And we can talk about that a little bit later, and you don't need to know exactly how that works. But ultimately, you get a very much more robust and full-featured way of saving your data for your app. So there are kind of some big things with this that we'll sort of be talking about progressively throughout the week. So today, all we're going to do is just make a basic task management app and have it store some data. And then as we go through the week, we'll be making this into a more and more full-featured app every day, sort of adding a little bit onto core data. So by the end of the week, you'll actually have a really, really solid foundation, and even, I would say, more than a foundational knowledge of core data, much more than I knew about when I was going about learning core data. So I'm super excited. I think core data is awesome. I talked about this a little bit last week, but people tend to have very strong opinions on core data, whether it's awesome or not. And I just want to be on the side of it's really awesome. You just need to use it the right way, and I'm going to be teaching you the right way of using it so that you don't, feel like like it's not a great tool, because it really is. People tend to sort of, I don't know, not know how to use it, and then they think it's a bad tool because of that. But are there any questions before we dive in a little bit into sort of the structure of core data? But does anyone have any just general questions about persistence, about core data in general?
What kind of data does core data do well with? I've heard it said that it's good with text, possibly JSON, not images. Is that about right?
Yeah, that's right. So it's really good at handling, sort of a big thing about it is it can sort of handle sort of relationships like a more traditional like SQL or MySQL, Postgres type of database. But yeah, it doesn't do super well just the way that it's written with storing large files. We can talk about how to get around that, but essentially what you do is you save the large file to like just the documents directory or somewhere on your phone, and you don't save it necessarily directly in core data, but you save the URL to that location where that file is stored in core data. And therefore you sort of get around not storing the large file, but you're just storing the text, which core data is fine with, to go and fetch that, image or video or whatever when you want to get there.
Okay. Last question. How well does core data play with JSON? Is it simple to work with, or is it?
It's we'll kind of look at that on Wednesday. Yeah, Wednesday. It isn't the most straightforward thing, and what I mean by that is like it's not like you could just give it JSON and it can immediately throw it into core data. You have to do a little bit of work, but it's not hard either. And you guys really already have a lot of the tools and knowledge to do that because you already know how to do networking. Does that answer your question?
Yeah, makes sense.
When we actually get into writing our core data model, I'll be sure to point out sort of the normal data types that we'll be using, and it's limited in a good way. All right. So let's talk about core data and sort of its overall structure here, because it can be a little bit overwhelming when we're using all of these things that have names of classes that you don't know about. So I just kind of want to dive in and talk about what everything is here. So if we, at the very start, have this thing sort of like a box that has a little window out here, this would be the so you'll see this NS come up a lot, and I'll talk about that in just a second. This is called the NS persistent container. So all you really need to know about the NS persistent container is that it contains everything related to core data in your app. So it's sort of like this, literally just this box that you sort of throw everything core data related into. This came out 2 or 3 years ago, a little bit after I started learning core data. So this didn't exist when I started learning, but what it does is it ultimately makes the setup of sort of everything you need to make core data work in your app a lot simpler. So it's basically like you initialize this one object and it will initialize everything inside of this box for you. It's sort of like, I don't know. I don't have a great example. I was going to say like a Lunchables, like you open it and it's got like everything you need inside of it already or something. Like, yeah. Okay, so then we've got 3 sort of main parts with this NS persistent container that you need in order to make your core data work. So at the bottom here, that's terrible. All right. You've got the NS persistent store, which for all intents and purposes, you could think of the hard drive of your phone. So the NS persistent store is where you ultimately store all of the information. That's like where the information gets actually sort of put when you want to save something. That's its ultimate sort of final location that it goes to. Then we have sort of on closer to, so I'm going to say like this is us out here. Us. We can look inside this window, but we can't really interact with anything except for this thing that's right here at the window, which is the, I'll put right down here, NS managed object. Oops. Context. So the NS managed object context is a really key thing, and it's by far the thing that we interact with the most, because what ends up happening is this NS persistent container sort of limits us from accessing directly anything else aside from this context. Well, it's not necessarily true. If you think about it like that, it ends up sort of working out for 99% of the use cases that you'll ever run into. So the NS managed object context is often described as sort of a scratch pad or a sandbox. So when you hear the term scratch pad or sandbox, what do you kind of think about? Like what do you mean by it? What do I mean by scratch pad or sandbox, do you guys think?
Is it that you can make it to be whatever you want it to be?
Yeah, exactly. Right. If if your teacher says, pull out a scratch piece of paper and you just kind of can draw whatever you want on it, notes. I mean, if you're paying attention, you draw notes. If you're not, you're just drawing whatever. Same with a sandbox, right? You could build whatever you want, and then at any time you could say, I'm done with the scratch piece of paper, I'm going to throw it away. Or maybe you have useful notes, and you're like, yes, I want to keep these around. Then you can go ahead and put that in your backpack or whatever. But it's sort of like in this weird intermediary state where it's like it could be something you want to keep or it could not be, right? That's ultimately kind of what I mean by a scratch pad or a sandbox. It's sort of this not quite concrete thing, but ultimately you can decide, yeah, what I've gotten here is good. I want to keep that around, or you can just kind of discard it. So if we say we made some changes in this manage object context that we want to keep around and save them, there we go, and save them down to the persistent store, what we have to do is we have this sort of intermediary object that is sort of a way for that information to go from that scratch pad and ultimately get saved to the hard drive. So I'll just kind of draw a box here. This is the NS persistent store coordinator. Okay, the NS persistent store coordinator, really its biggest job is just to go from here to here and then take that information up to and from the hard drive. So we could say, I made some changes here, and I say, I want to keep those changes. The persistent store coordinator can grab those and ultimately throw those. Well, I shouldn't do that. I should go through the persistent store coordinator and drop them into the hard drive so that they can get saved. Then when we...
So, I have a question.
Yeah.
So is core data this whole process?
Yes. Yeah, think about it as like a bunch of individual classes and functions and properties that Apple wrote in order for this whole thing to work, this whole process of saving and loading to work. And they just kind of blanket termed it with core data. Just like, for example, everything you do in the storyboard, it's a UI view or a UI text field. Those are all a part of UI kit. So it's sort of, they shove everything related to sort of what you're trying to do into what is called a framework. And it just is sort of like a very specific functionality. Does that make sense?
Sure. It does make sense.
Okay, good. All right. So then we say, okay, cool. Well, now we've got this down here, but maybe, over here, we opened the app the other time. So we were kind of in this reverse situation where the stuff is down here and we need to get it up into the manage object context. The reason for that, again, is us as the developers out here, we can really only interact with what's in this context. And so we can't directly access sort of the hard drive or where those files are actually stored. So what we have to do is we perform what is called a fetch request, and we say, hey, basically, go grab, my changes or my, I'm just going to say saved data. I promise I know how to spell. So you make this request that says that, and then you give that to your manage object context, and the context then sort of performs this whole communication that says, hey, persistent store coordinator, I need you to coordinate between me and the persistent store, and I need you to grab this data that the app wants. And so it says, okay, sweet, I'll grab this and go back up this way and grab those changes. And then once those changes exist on this managed object context, we're able to do things like, display them on the table view or, edit them, do whatever we want. So this sort of back and forth between the context in the persistent store is effectively able to transpire because of this NS persistent store coordinator here. It's the one that coordinates between the persistent store and anything else in core data. Any questions? On a conceptual level, can you give me a 1 to 3 on how you feel your understanding of sort of this overall flow is with saving data and getting data back out? I'm not looking for like, do you know how to do this in code? Because we haven't looked at that yet. But like conceptually, do you understand what's going on here? And if you have any questions, please feel free to ask.
Excuse me, just to have something to like compare it with. It's kind of like the model view controller pattern, where the controller kind of is the one in between.
Sure. Yeah. Everything just has their own job, right? And that's why these objects are all separated out. And then it's like, you know, for example, us maybe sort of is actually represented by the table view. We have to get that information to show on the table view somewhere. And so we just ask the manage object context for that information, and then it performs that request to get the information. So yeah, in a similar way, you're sort of going through a similar sort of pattern of asking objects for some information to ultimately get that information back. Is that kind of what you mean?
Yeah. I was just trying to get something similar to it for the pattern wise. I know we haven't really got into the coding part, but
yeah,
that's good.
Another way I've heard it is sort of explained, and I don't think it works super well, but for example, if you go to a restaurant, this would be like when you want to like pull some data out. If you go to a restaurant, you make a request for some food by, you know, asking the server like, hey, I want a grilled cheese sandwich or whatever. That would be sort of like this request here. Then the server is sort of the persistent store coordinator. And so by you saying, hey, go grab me a grilled cheese sandwich, they say, okay, cool. And they, you know, go down, and this could be like the chef. The chef makes the sandwich, gives it to the server, and then ultimately kind of gives it to you. It doesn't really work for saving data, but it works for sort of getting data back out. But in a similar way, that's how I've sort of also heard it be explained.
Can I ask an additional question on the persistent container?
Yes.
Are there going to be more components in the container that interacts between the interacts with the persistent store coordinator and the persistent store? Yes,
there can be. So as an example, this is the most basic setup for core data and just the one that comes by default. On Thursday, we'll be talking about sort of more complex ways of setting up core data, but ultimately what it would look like, and I don't want you to stress out about this right now, but what it could be is that you actually have multiple sandboxes. And so now you have, you know, sort of like a couple windows over here, or maybe you've got 3 or whatever. Or in theory, you could also have multiple persistent store coordinators. Generally, you could if you in theory wanted to, but you generally always have one persistent store. But as far as the persistent store coordinator and the contexts go, you can in theory have more than one. And there are some reasons that we'll talk about on Thursday about why you would want to do that.
So that's basically the main reason why we have the persistent store coordinator, because of multiple things, and the persistent store coordinator just acts as like the middleman for everything, right?
Yep.
Okay.
Yeah, that's a good way of looking at it. It can get more complex when you get multiple coordinators, but yes, essentially yes, that's how I would think about it.
Yeah, because the reason I'm asking this is because, like, in this situation, it just seems like it's it's redundant because there's only the store persistent store and the object context, and it just seemed like that middle part is redundant because you could go straight through it.
I see what you're saying. So if there was no coordinator here, the way that they're written, there is no way for them to communicate. So there's this very large gap between the two, and so there would be no way for them to communicate directly, just the way that they're written. So on purpose, the persistent store coordinator is written so that it's fine to just handle one, just one context and one persistent store, or multiple. But yes, I mean, if there was never the time where you would have multiple, yeah, in theory, they could have just wrote it so they could communicate directly, if that's what
Gotcha. Yeah, gotcha. Okay, thanks.
Yep. Any other questions before we dive into the code here? Okay, cool. Let's go ahead and get this going then. Let's go ahead and open that starter project. It should be in the iOS 10 channel if you need it. So, all right. So let's talk about what we have here. You'll see that the project is largely empty. The only thing that it does have is just this, this storyboard with a view controller for showing a list of tasks, and then a detail view controller, excuse me, that is just going to let us view the details of an existing task or just create a new one. So let me go ahead and run the simulator here. We can look at the completed project, although I think it's fairly straightforward. So, I need to update the starter project so it works with dark mode, but that's okay. Just turn that off for now. There we go. Okay. So we can create a task. We can go back into that task and view it and update it if we wanted to. But the cool part here is if I close the app and then I rerun it, the task is there again. And so now we're actually getting into, making data stay around longer than just as long as the app is running. And I know you guys have done this with Property List Encoder, and that was just sort of like a good introduction to what persistence is, but in any real app, you wouldn't do it that way. You would probably just use something like Core Data. So let's go ahead and start where we would normally start, which is the model. We've sort of already got the views set up. So in order to make a view controller, we've got the views set up. In order to make a model controller, we need the models. So we're going to do something different though, because we are using Core Data. We don't actually create a Swift file here and call it, like task or whatever. But we're going to go down, and if you scroll down, it's this third section called Core Data. We're going to use this data model file. And tomorrow I'll talk about what a mapping model is, but for today you don't need to worry about it. So this data model file, it follows a fairly specific way of naming, and I've seen students not quite follow this in the past, and then they've had problems, especially during the sprint challenge. So I'm going to be very explicit here. We name this file the same name as our project. So I'm going to call it tasks. More than anything, that's because of just sort of normal convention. And then I'll send you a sort of a trick, but I would kind of want to do it manually today. So we're going to call it tasks because that's what the name of our project is. And what it's going to do is it's going to create this tasks.xc data model D file. And this looks a little bit more different than anything we've seen before. So the purpose of this file is for you to essentially create your model objects, but basically make them able to be stored in core data. So what ends up happening is you can't just store anything you want in core data. It sort of has to have basically a certain set of functionalities in order for it to sort of be stored in core data. I'll talk about what that is in just a second, but if you want to save anything using core data, you need to write it out in a data model file like we are here. Okay, so let's make a new model object. So what we have are sort of these three sections, and we're only really going to talk about entities today. But if you go down here at the very bottom, there's this Add Entity button. So go ahead and click that, and then we'll get something in this sort of main section here that we can actually use.
So sorry to interrupt. I'm trying to make the new file, and I'm getting the error. It already exists. I haven't really added any other file. I just downloaded the project.
Oh, weird. Okay. You can just replace it. That's fine. If it asks you, yeah, just go ahead and replace it.
Okay, thanks.
Mm-hmm. I need to take that out of the starter project, but I didn't know that still existed. That's weird that it didn't yell at me. But so we have this entity. So what an entity is your model object. You can think of it as whenever you see the word entity, just think of a model object. It's essentially the same thing, but when it's using core data, we just call it the entity. So what I'm going to do is you can either double click or tab enter or return to be able to actually change the name of this. So I'm just going to call this task, and I'm actually just going to rename the entity to task. And that is like me saying task, or this is like me going into a new Swift file and saying class task or struct task. I'm just giving it a name, a title here. So then we have these attributes. So attributes would be like properties. So if I said we want to, make a task object with some name and notes, it would probably look something like this. So just go ahead and watch me here. We would probably say like struct task name notes, right? So we just say, hey, let's name this property name. Let's give it a type of string. Let's do the same thing for something called name, for notes, and its type is going to be string. Oh my gosh. That's essentially all we're doing here, just in a sort of a different format. So an attribute is just like a property. So what we can do is just hit this plus button, and then we can give the attribute a name. So I'll call it name. And then we'll set the type here. So this type, it just gives you a drop down. And this is a little bit interesting because it's basically limiting us to what we can actually make the type of any individual property be. It can't be whatever we want. So we can have integers, decimal, double, floats. We've got a bunch of number types. We've got a string, a Boolean, a date, which is actually really cool. Binary data, which would just be like data, a UUID, which we'll talk about tomorrow or maybe Wednesday, a URI, which is basically like a URL, and transformable, which is kind of like any. I don't want to get into sort of any of these last ones today, like especially like UUID, URI, transformable, binary data. It's a little bit not more advanced, but just kind of not related to any of today's projects. But I will talk about them. So we're just going to say that we want this to be a string, and we'll do the same thing for the notes. So what I want you to do is go ahead and save this file. Just hit Command S. Then do Command B and just build the file. And then just for fun, let's go to like the app delegate because it's like the only Swift file we have right now, just so we can have somewhere to run some code. And just in this did finish launching with options, all I'm going to do is I just want to illustrate a point here. I'm not actually going to run any real code in here. But what's interesting is if I start to write out the class task,
Import core data possibly?
no, I shouldn't have to. Well, that foiled my plan. It should be, and maybe it's working for you. You should be able to see that there is something called task, and it should automatically generate this for you. Is it working for anyone? No? Weird. Okay. That's kind of bizarre because I've never had that happen before in my life, but okay. So what I wanted to point out was that you can actually have these tasks, or sorry, these entities, these model objects, essentially generated for you. So every time that you change an attribute on here, you either add one, or maybe you're like, oh, well, I want the notes to be afloat for whatever reason. It would, in theory, automatically generate that class file for you, and you wouldn't have to like write out any code in order for that to actually sort of propagate to the code. It would be able to autocomplete and everything with that new float type or whatever. The way that that works is the entity. So if you click on the entity here, you can see that its code gen is what's called class definition. This has now been the default since Swift 3, so about mid 2016. And what it means is it's just going to automatically generate those for you. The default used to be this manual none, and it was actually that you had to create the entity like we just did here, and then you would actually have to say, all right, now let's go ahead and basically export a Swift file, and it would generate a Swift file with this same code in here, which was kind of like doubling up on your work, and that's most of the reason why the class definition exists now, so you don't have to do that. Okay, so one other thing I want to talk about in this class file, or sorry, in this data model file, is if you click on the attributes, you should see this little window here with this tab called the Data Model Inspector. If you don't see something like this, when you click on your attribute, if it's just sort of blank, like it kind of looks like that, sometimes what you have to do is click on the entity again, so task, and then click on the attribute, and then it should show up. It's a little bit weird. Maybe they fixed it in Xcode 11, but. So here's kind of like the attributes inspector of this attribute, right? We can change different things about this, this property. Sorry, I'm getting a call. So I don't want to dive into this too much because there's stuff that we don't really need to talk about right now. But you can do some cool things like set this to be optional or transient. And this derived is actually new. I need to look into what this means. And I mean, it's new as of Xcode 11. So I haven't looked at it yet. But optional doesn't quite mean what you think it means. And we'll be talking about that tomorrow because that basically has to do with tomorrow's guided project. You can also do cool things like give them default values. So you could say, maybe I want my string to always start off as foo for some reason. Like it will, every task you create from there, it will have a name of foo until you change it. So you could do that. Not that it's super useful all the time, but there are definitely times that we'll be doing it. Actually, tomorrow is one of them. And then you can also do things like sort of say, I want this string to be within this range, right? I only want it to be 3 characters or more, or up to 20 characters, whatever. So you can kind of limit it that way. And then the index and spotlight and preserve after deletion, you don't need to worry about. And we can talk about them later, but I don't want to get into it right now. It's not really worth the time right now. So ultimately, to break this, this data model file down into sort of a single sentence of its purpose is you create your model objects here and they will be automatically generated into actual class files or classes from this file. And that also makes them so that they're compatible with being able to be saved and loaded from core data. Are there any questions about this data model file? We feeling okay so far? Okay. One thing I want to point out, not that we're going to do it in this project, but if, for example, you had a project with multiple model objects, if you wanted to make, another, model object called person or whatever, all you would do is you just hit this add entity button and then go ahead and, call it person. Oops. Person. There we go. And then add attributes to that and everything, and it would generate that as well. So you don't have to make a new data model file for every model object you have. You can just use one, and it will. You can add as many as you want in here. We'll be coming back to this tomorrow, so I know there's stuff I haven't explained. We will get to that tomorrow and maybe Wednesday. All right, just for fun, let's see if it's now going to work. Yeah, there we go. Okay, I don't know why it wasn't working before, but now we can see that like this task exists, and I can go ahead and create one and say dot name or dot whatever, and it should be fine. It's going to yell at me here because it's like not going to have a name. And it knows like, hey, this is a string. Cool. So at the very least, we can see like our code is recognizing that there is a class called task, even though we never wrote one in code. That's all I wanted to show here. Okay. So before we take a break, I think we should have time to talk about the core data stack. So going back to our example here, I said everything related to core data exists in this NS persistent container, right? So what we're going to do is create a file that's going to help us set up this persistent container. And it's also a great candidate to be a code snippet. Although we are going to change it a couple times this week, I don't actually think it's a bad idea to keep multiple versions of this code snippet either. So let's go ahead and make a new file here. And this is just going to be a normal Swift file. We're going to call it core data stack. Just like that. There's not really anything special about this name other than it's just sort of a common way of naming it. So I think this is really the first time that we've ever had to do anything like this, but now that we're using core data, everything related to core data is actually in its own framework, kind of like we were talking about earlier. And what that means is I actually need to import core data in order for my code to recognize that we essentially want to use core data and it's, access all of the classes and properties and everything that are a part of it. So I'm going to make this a class called core data stack. Now, this isn't necessarily anything, this is where MVC kind of doesn't quite handle everything. Like this core data stack is like more than anything like a helper to a model, like of models, but it's not like a model. It's not necessarily a controller. More than anything, it's probably a controller, and it's not a view. So MVC is great to sort of shoehorn in most things, but it doesn't work for everything, and that's okay. This is more than anything just a way for us to create model objects, well, yeah, never mind. That's getting confusing. So what we're going to do is we're just going to set up a persistent container. Then we'll also make a create easy access to the mock. So mock means whenever I put mock, just think managed object context. So this thing right here that we generally have access to, because we're going to be accessing it a lot. Kind of creating easy access is nice. And we'll get into that in just a second. So first of all, let's talk about setting up the container. We're going to do a couple things here, and I want to write this out, and then we can talk about kind of what it's doing. So we're going to create a lazy variable. If we haven't talked about lazy, I'm more than happy to go into it, and I don't think we ever have. So, but it's an NS persistent container. Now what we're going to do is just create a closure right here. That's going to set up the whole container itself. So the first thing we're going to do is actually create this container, and then we have to do a little bit of setup. So I'm going to say let container equal NS persistent container. And if we open up the initializer here, we'll use the one with just the name. And what we do is we give it the name of our data model file here. So in our case, we'll just say tasks, and then it knows to basically set up a persistent container to be able to handle saving and loading and interacting with any of the entities in that data model file. So for us, it'll just be tasks. This manage object model one is a way for you to say, hey, I only want to load essentially part of this data model file. So again, maybe we had that person, so you could say, I only want to set up this persistent store to set to save and load person objects or whatever. I've never personally used it, but that's what you would use it for. So all we're going to do is say tasks right here. So here's the key thing. This is a string, and it's easy to mess up. And I'll give you a code snippet later, probably maybe tomorrow or maybe this afternoon. That will make it easier. But whenever you say, what do I need to put in this name, you should think, oh, it needs to be the same as my data model file. That's essentially what it's looking for. Actually, that is what it's looking for. Not essentially, that is. So then what we need to do is basically sort of initialize things and set them up and be ready to be, really what ends up happening is we need to say, go and grab all of the changes and put them in the persistent store so they're actually able to be, fetched and interacted with. Just because you initialize the container doesn't actually go ahead and grab everything and put it in the persistent store. So all we have to do is we need to say container.load persistent stores. And we get this completion handler with this persistent store description and an error. What I'm going to do is just underscore the description because we don't need it. And what I am going to do is grab the error though. So if we look at this in the documentation, it says, once persistent container has been initialized, you need to execute this function to instruct the container to load the persistent stores and complete the creation of the core data stack. What the core data stack is basically, for all intents and purposes, the entire container. Before they used to be individual objects that you made, and now it's really just a container that sets up this whole, what you would call a stack of objects here. So the only thing we're going to do in this completion handler is check if there's an error. This is something I can't overstate because I've seen this in students' projects where they don't do this, and then, which is weird because we end up making a code snippet of this, but I've still seen it, and they don't know what's going on. So what we're going to do is if there's an error, I'm going to actually use a fatal error. Has anyone ever talked about fatal error before with you? No? Okay. What it does is it crashes the app on purpose. So fatal errors should be used pretty infrequently, but this is a time where, for example, again, if we think about a journal app, if you are unable to set up your core data stack, everything related to where the journal entries are being saved, if something goes wrong there, then, and you're not able to load things or save things, then you probably don't want to crash the app because you're dealing with the user's information. If something isn't working and you keep going, in theory, you could run the risk of potentially corrupting their data if things don't quite work right with core data or whatever. So to be on the safe side, what we're going to do is we're just going to say, I'm going to crash the app. Also, if the app crashes here, it's probably going to crash in development, and very unlikely is it going to crash, when the app is actually in the App Store. So what we're going to do is we get this nice opportunity to, instead of just like force unwrapping where it crashes the app, it actually gives us an opportunity to print a log message and actually say why the app is crashing, which is awesome. So what we're going to do is just say failed to load persistent stores, and we'll interpolate the error so that core data can tell us in this error why it's not working. Generally, the reason that it doesn't work is because you named this string wrong. So in this, it would be really easy to be like, oh, it needs to be called task because that's what my entity is named, but it actually needs to be the name of your file. So at the very least, crashing the app and letting us interpolate this error is going to let us know why it's not working, and we can fix it quickly. And then finally, we just need to return the container. So the setup is sort of a two-step process, and that's why we're using this closure here. Closures are great for like a store property like we're doing here. We're giving it a default value, but instead of just saying like, NS persistent container like that, or just giving it the tasks, like ignoring this, sorry, that looks a little bit weird. Ignoring this is great, but again, just like we looked at when we called this load persistent stores method, you actually need to call this method in order to sort of complete the actual setup and initialization. Without this, it's sort of like a half-baked thing. And so we use this closure to do multiple things before we ultimately set its value. Aside from lazy, which I'll talk about in just a second, are there any questions with this as far as what it's doing, as well as like syntax? Because I know we haven't used like closures to initialize stored properties probably too often.
I guess with just some clarification on the fatal error, you primarily use it for development purposes, right? And then in the future, if you still wanted to log something to say perchance something did happen in the future, would you like NS log it so that it doesn't intentionally crash the app when users start to use it?
Yeah.
Or what would you do? Yeah.
I mean, it depends, right? I still think that keeping the fatal error here, at the very least in this specific use case, is probably a good thing to have even when you ship your app to the App Store, because again, we're dealing with the user's data, and it's probably a bad idea to get into the situation where we can potentially corrupt their data. If it's something more benign, like you're not able to fetch some information from an API, like the API is down, like that's the time where you can be like, yeah, I'll just like send an alert controller to the user and be like, I couldn't get this data. Like, it really depends on sort of what you're doing. Fatal errors are great though, yeah, for development, for sure. But there are definitely times to keep them and times to also replace them with something else. That's probably not a great answer, but that's really how it is. So, oh yeah, go on.
Yeah, I just need some clarification on closures. Mm-hmm. For closure, you're telling compiler to load some code after a certain event or after something is completed or done, right?
I mean, yes, they can be used like that, but in this case, it really all it is just sort of a function that we're making, but we're not actually creating the whole function itself. It's just, we're just running a chunk of code. That's all it is. That ultimately a closure is just a chunk of code.
So why use a closure as opposed to just, you know, writing a statement?
Well, in this case, we can't write a multiple line statement like this without the closure. If we're trying to just give it an initial value without all of this stuff, we can't actually, like if we do this, we can initialize objects on one line like this, and that's fine. But then we can't, you know, on the next line say like container dot whatever, because that's not in a valid place where we can run some code. Does that kind of make sense? If you really wanted to, you could actually create a function that does the same thing, and then you just set the value equal to the result, like calling that function, but it's like more work for you, and you would never want to call the function again. And that's why closure in this case is really great.
Okay, got it.
Okay. I'm going to open up just a throwaway project. I just want to illustrate a point here. So you don't need to create this or anything. Just watch me here. I kind of actually want to keep that stuff around though. Okay. Let's see, how can I illustrate this well? Lazy is like this weird thing where I'm not like quite sure how to explain it well as far as making the code work. Here, let's try this. Okay. This is like, yeah. I hope this makes sense. Here, I'm actually going to make it more like what the or like what we're looking at with the core data stack. So I can put a breakpoint here. Okay. So what I'm going to illustrate here is like I'm just doing some work just so that you can see it's not like immediately happening here. But if I run this here, watch which breakpoint gets hit first. Okay, so we see that it's this foo here on line 13. What this is saying to us is as soon as this view controller is initialized, as soon as it's created, it's going to go ahead and create and initialize all of its individual properties, like this foo property that I have here. So then, if I jump down here, it's then going to run this for loop, and then it's going to print foo, right? That's cool. Sometimes you, for whatever reason, and I'll talk about the reason for our core data stack in just a second, or that container specifically. Sometimes you don't want that actual behavior to happen where as soon as this view controller is created, you don't want it to create this foo variable. So what we can do is we can say this is lazy, and this is like performing lazy loading. And so now if I run this again, it's going to hit these things first and then access foo down here. So it actually doesn't go ahead and create this variable until it's tried to be accessed the very first time. So now if I hit 26 and it's about to print it, we're trying to get the value here. And so then it's like, oh, cool, now I need to initialize myself because it's just kind of sitting there, not taking up space yet. And then it jumps up to line 14 and actually gives it a value. Does that kind of make sense what I'm trying to say with lazy here? Just doesn't quite get loaded as soon as everything else is created, but only when it's needed. So, whenever you want to access it is fine. It's just that very first time that it's accessed is then the time that it actually gets initialized. Right? And if I, for example, don't print foo here, I don't have anything, we'll see that this line 14 never gets run. You can hit line 22. We can see it just never hits 14 because nothing ends up using it. Any questions on lazy here? Conceptually? Okay.
What's like the advantage of a lazy bar then?
What's the advantage?
Yeah.
Yeah, that's a great question. Sometimes it's as simple as you don't quite want something to load as fast as it would. So as an example here, this is a perfect example. When we set up the core data stack, generally this core data stack, the way that we're going to write it here in just a second, it's going to load things before the app actually has time to sort of be fully set up to handle like making and loading this persistent store. So what we do is we give it just a little bit more time, like literally just like wiggle room as far as time goes, so that the app itself can finish loading, and then by the time that we call, our core data stack.container, it actually will be able to load the persistent stores. I'll try to show that to you when we actually get our app running. So it's just a way to do things later. Sometimes it's like you've got some huge object that you don't want to have taking up memory until you actually need it, right? Or it's just you need it to happen a little bit later. I guess those would be kind of the main times that would happen.
So from your example before, right, where you say you don't want this persistent store to load up yet, it's, I guess for that example, it's for the sake of UI, so that it loads up the user interface first, so that the user can see something, instead of having the store load in the background and delay the user interface, right?
It's actually even simpler than that. Sometimes it's that, literally, if this persistent store tries to load too early, the app will crash because it's just not able to, it's just not ready to load these things yet.
Okay, all right.
Why it's just whatever behind the scenes just isn't ready to sort of handle, the initialization of or rather the loading of the persistent stores is where it crashes, and it would hit this line 21 here. I'll try to show that. Sometimes it crashes and sometimes it doesn't, and that's what's a little bit hard about this, but maybe we can get it to not work if I make this not lazy.
Okay.
We'll come back to that. All right, let's go ahead and take a break, and we'll come back in 5 minutes, and then we'll finish up the project. All right, welcome back. All right, we'll get started in just a second here. Did anyone have any questions come up during the break that they want to talk about before we continue? Percy, were you asking a question or?
No, I'm fine.
Okay. I just want to make sure you didn't like accidentally mute yourself. All right, let's go ahead and jump back in. So what we got here is this function, again, is setting up this whole container. And that's the cool part about this. Before, like when I learned core data, you had to do the work where you'd have to create the manage object context yourself, then the coordinator and the persistent store sort of all individually in this core data stack. And now the container just does that all for you, which is awesome. So what we're going to do is like I just said, it creates everything for you. And on a container, you've actually got what's called the view context. So by default, it just creates one manage object context, and it's called the view context. We're going to do this thing for a couple of reasons. One is to create easy access to that view context, and then we'll talk about the other reason on Thursday. But what I'm going to do is just make a computed property here called main context. That is an NSManage object context. And we're just going to simply return the container.viewContext. I think, not that you need to do this, but I think now you can actually just do container.viewContext and it automatically returns it. That's new as of the latest version of Swift. I think we're on 5.1 right now. So either way, if you've just got a single line that a single object that is being returned, it just infers that return statement, which is kind of cool. Really, it's mostly used for like, it basically exists because of like Swift UI, I think. But so we're doing this.
Sorry about that. Is this the coordinator then?
No, this is this context here.
Oh, I see. Thank you.
So this is the thing that we'll be interacting with the most. This is, again, sort of that window that we have access to. This is our window here where we create the container, but we're not accessing directly like the persistent store or the coordinator, but we are going to be using this context. So we sort of make this variable for easy access. What I mean by easy access is when we end up calling this, it's going to be like core data stack dot container dot view context. That's three things, and it actually would be four, and I'll explain that in a second. Now it's just going to be core data stack dot main context. It's one less sort of dot thing that we have to do. That's one reason. And we're also kind of giving it another name, and that's what I kind of want to talk about on Thursday. That's not necessarily anything that you have to worry about right now.
Spencer?
Yeah.
Okay, I recognized line 28 as computer property, right? But then it just kind of looks very similar to line 16 also.
It does.
So what I guess the equal sign is the thing that sets them both apart?
Yes, so the equal sign is actually giving a value to this container. So we would say that this variable is a stored variable, or it has it's rather a stored property is what you would call it. It stores some value, right? It's sort of like, what ends up happening is, actually I can illustrate this back if we jump back to this foo example. So what I'm going to do, it doesn't matter if this is lazy or not. Oh. So as an example here, we're going to hit line 22. It's going to jump up and hit line 14. But what's interesting about a stored property is now that this has been set up, when I hit line 28, you'll see it won't go back up to 14 because it already has a value. It's stored that value, and so it doesn't need to, run this closure again to return foo because it already knows its value is foo. Like it's sort of set in stone from then on. So it's sort of like making it constant in a way. Whereas if we make this a computed property, we're saying, hey, this is kind of some, actually shorthand syntax. But now if we look at this, the computed property is going to call it every time. So if I print foo here, jumps up to line 14, print foo on 28, it jumps up to line 14 again. That's because it's going to be computing that value over and over. Every time you access it, it's actually going to be running this here. Does that make sense? Ish?
Yes, I just didn't recognize the syntax.
Okay. What's actually interesting about this is actually shorthand for just writing a getter. So this is the exact same thing. It's just that if you don't have a setter, you don't actually have to write this get here, and it just infers that this is a getter. So these are the same things. This is the same as just that. But that's kind of the difference. The syntactically, the difference is very subtle there, right? But really, you can ultimately sum it up by, yeah, there's an equal sign here, then it's a stored property. If not, it's a computed property. That's a great way of looking at it. Okay, the last thing we're going to do is we're going to make a static let shared equal core data stack. This is like one of the biggest, like, with great power comes great responsibility type of things in code as far as design patterns go. We don't use this pattern very often. This is called the shared instance pattern, specifically what we're doing here. Very closely related to that is what's called the singleton pattern, which you might have heard before. We purposely don't use this very often in the curriculum because it's something that junior developers tend to abuse and overuse quite a bit. We actually have a whole guided project in a couple sprints about Cocoa design patterns, and we talk about this pattern here. But ultimately, what it does is, what it's going to do that we kind of care about right now, it's not its main purpose, but it will let us access the core data stack class from anywhere in the app. That's not its real main purpose, but ultimately that's kind of what we care about here. That's what I mean by it's not its main purposes. That's not why you want to use the singleton pattern. But now, for example, if we wanted to use the core data stack, we wouldn't have to pass it around in the prepare for segue from view controller to view controller, or pass it around from one model controller to the other. There are some huge implications with that, and I'm happy to kind of have a preliminary discussion with about this, maybe on like Q&A or something. But ultimately, that's what it's going to let us do, is access the container, and more importantly, the context from anywhere in the app. So what I mean by that is we could go into the app delegate, and without creating an instance of, we don't have to say like let core data stack up here. We can say core data stack dot shared dot main context, and we get access to the context. So this shared plays the role of the instance of the core data stack that we make, and so we don't ever have to initialize a new core data stack to get that context. That's essentially what's going on there.
So is shared a reserved word?
No. It's sort of commonplace. What we would call this in like Objective-C, for example, and also older Swift, would just be like shared stack. But no, it's not a reserved word. It could be.
So basically, we could use whatever word we want, right?
Yeah. Okay,
got it.
As far as like if you called this something different other than shared, I would be a little bit weirded out. Generally, most of the time, it's called shared. We've used things similar to this, and this is why I would be a little weirded out, but not totally. You've used user defaults before, and we've used this standard. This is the same thing. We say user defaults.standard dot whatever for key. This is that same thing. It's just a shared instance. Or URL session, right? URL session dot shared dot data task with URL. It's just a shared instance.
So we're basically writing it like that so that we could have access to core data stack, you know, when we want to do the shared dot thing,
yeah.
The notation. Okay, got it.
All right, so we've actually got a lot of the code written now. We just need to make like a very basic model controller and like write out our view controllers, and we're basically done. So let's go ahead and do that now. Let's go ahead and there's actually one thing we need to do before that. So let's go ahead and still make a new model file. So we're going to make a task plus, sorry, this is a Swift file. We're going to make task plus convenience as a Swift file. There's no special, like, this is just a standard naming convention, but there's nothing special behind the name other than it's just standard practice to do it like this. I'll talk about kind of this syntax here. So if you need, the file name is right at the top there on line 2. This task, like this, whatever the class is, plus whatever, comes from Objective-C essentially. And what it is this is how you would make like an extension to a class in Objective-C, and it just sort of carried over in Swift. So it's the file that you're sort of extending, or the class, the type you're extending, plus sort of what you're extending it with. So what we're going to make is a convenience initializer. So we call it plus convenience. Other than that, there's no like special naming, you know, there's no meaning behind that other than that. So we're going to make an extension here on our task. So the reason we're making an extension here is, again, this data model file is in charge of actually creating the task. We saw that in the app delegate, we had access to that class called task, and it existed. So what we want to do is add a little bit of extra functionality onto it, but ultimately, like we, you know, create a class called task here, it's going to yell at us and say, hey, there's already something called task. You're trying to redeclare, you know, a class that already exists, and so it doesn't get happy. So we just make an extension here. So the problem here that we run into is, just watch me here. I'm going to go back to the app delegate. If I want to make a task object, like if I go back to, oh, it's not open. If I go back to here, like we look at this struct task or class task, it doesn't matter. I say like, you know, my task. When I open this initializer, we're greeted with this very normal looking initializer. We pass in a name, we pass in some notes, right? We're just passing in individual values to initialize each of these properties here, right? We're all familiar with that. Okay. The problem here is in our code, in our project here, if I try to do the same thing, I say let task equal task, we're greeted with some not so familiar initializers. And the reason is we're using core data here. It's sort of building out a very basic form of our task object, but it's not the most user-friendly thing. And I think this is where a lot of the sort of like displeasure around core data begins to happen, is because they don't know quite how to make things feel a little bit more natural like we're used to. And so that's what we're going to do. So in this task plus convenience, we're just going to make an initializer that basically follows that same pattern of, you know, passing in each individual value, each individual property into the initializer like that. And I'll talk about what convenience means in just a second, but go ahead and write it with me. So we're going to say convenience init, then we'll make a name and notes, because that's what we have. Those are the properties in our model object. But we're also going to include one more argument, and we're actually going to need to import core data first. Otherwise, it's not going to recognize it. And it's the context. So we're going to say NS manage object context here. All right. So let's talk about kind of how, how model objects end up working in core data. Just watch me here for just a second. If I look inside of this task class, this is a little bit interesting, and we're going to kind of revisit this on Wednesday, but it says this file was automatically generated and should not be edited. So this is, again, the reason why we sort of end up making an extension is because if we wanted to, I could actually say like, oh, will it not even let me anymore? Oh, shoot. In Xcode 10, it would totally let you edit the file, which was actually kind of cool because what would happen is you could edit this file, and then as soon as you built it, it would just put it back to the way that it is now, and you would actually see like it gets regenerated every time that you build the project. But now it won't even let me edit it, which is kind of lame. But we see that this task is a subclass of what is called NS managed object. So let's look at that in the documentation. So it says that it's the base class that implements the behavior required of a core data model object. So, in other words, anything that wants to be a model object in core data has to be an NS managed object or a subclass of NS managed objects. So it's got sort of the base functionality to make it so that you could save things, you could save them, edit them in core data, load them from core data, et cetera, et cetera. So it just has that base functionality, and then from there you build off of it by saying, hey, these are my properties. I've got some name, or I've got a name, and I've got some notes. That is ultimately what creates the entity called name or called task with that specific functionality on top of it. So what that means for us is we have to sort of set up the base NS managed object part of our task before we can give it a name and notes. So we need to, if we look at this, there's an initializer on NS managed object that takes a context. So we can say, let's give it the context first. And so what that ends up doing is it's like us going into here and drawing in, this specific, like this specific scribble is a task or whatever. Maybe they all look like this. And then we say, well, this task has specifically like this name and these notes or whatever. Does that kind of make sense? So you kind of have to have something there before you can add on to it. So what we're going to do is in this convenience initializer, we're going to say self.init. And for whatever reason, man, I wish they would have fixed this in Xcode 11, but they haven't still. We need to call that context initializer. So it's context, and we're going to pass in our context like that.
So what do you mean by you wish that they fixed it? Is it not supposed to call context?
No, well, if you call self.init, in theory, it should pull up the initializer, but it doesn't.
Oh, I see. Okay.
So if you want to get around that, like if you don't want to remember like what this is exactly formatted as, what you can do is call it task.init, and then it will pull it up like this and give it the context, and then you just replace task with self. It looks the exact same, but it's just if you want autocomplete, like.
Gotcha.
It's been broken since Xcode 10. Xcode 9 was fine, but. All right. Ultimately, what we're doing here is we're sort of setting up this base NS managed object. So what I think of it as is like if you're drawing a picture, we all start with a sort of blank piece of paper or blank canvas. You all start from the same place. So every NS managed object starts out as that blank piece of paper, but from there, you're able to make it your own, right? You like maybe Jesse's drawing a bird, maybe Austin's drawing a building or whatever, and we all sort of make them out to be whatever we want. So we're going to draw this out to be a task in this case, But to start off with, you have to do this self.init and actually put the paper on, on the table. Otherwise, you have nothing to draw on. Does that kind of make sense? Okay. So from there, what we can then do is now treat this like a normal initializer where we say self.name equals name and self.notes equals notes. So just to sum this up, this initializer sets up the core data in this managed object part of the task, then gives it the properties unique to a task entity. That's probably a little bit like overkill as far as explanation goes, but if that helps you, that's awesome. The biggest thing I want you to remember here is that you need to call self.init here very first. And in order to do that, we're going to include this NS managed object context because that's what the initializer requires us to do. Let's talk about convenience for just a second. I don't want to take up too much time here, but if we're talking about. Again, going back to the Swift programming language guide, which I think is an awesome tool. It has the section on initializer delegation. And also ultimately what we're looking at is the difference between a designated initializer and a convenience initializer. So it says a designated initializer is the primary initializer for a class. It fully initializes all properties introduced to that class, and then I'll get to this in a second, but it calls an appropriate superclass initializer. So it says classes tend to have very few designated initializers, and it's common for a class to have one. So for us, probably up to now, we've always been using designated initializers. I don't really think there's a time up to today where we haven't used a designated initializer. So if you don't put convenience, for example, that's basically like a designated initializer. And so what the designated initializer is this one right here. So just behind the scenes, core data is creating this self or task initializer called init in context, and it actually sort of ends up coming from this one. And the way that it actually works is a little bit confusing because we're not able to actually see this chain of initialization quite as easily as we could on other ones. But what we end up doing is we use a convenience initializer, and that says that it's a secondary supporting initializer for a class. So you end up calling a designated initializer from the same class as the convenience initializer. So that's what we're doing here. So you have to call a designated initializer or another convenience initializer in a convenience initializer. There's a diagram that sort of helps explain that in a second. And so the difference between a designated and a convenience initializer is you do not have to provide, that's not what I was looking for, sorry, hold on. No, shoot, I lost what I was looking for. Anyway, there's this nice diagram here though. So what we've got is essentially this pattern here, where if we think of the superclass as NS managed object, it's sort of this base core data class that we don't have access to. The subclass would be our task. What we're doing is we're creating our convenience initializer right there in our code in your project that you can look at right now. We're calling self.init, which is the designated initializer. So it's setting up the NS managed object part of it. And within that designated initializer, if there's a superclass, which there is in this case, it will then call the designated initializer for the superclass. The reason for that is you just want to make sure that basically every part of this object is initialized and created. So for example, if we only, it's going to yell at me here and that's okay, but if we only set up the name and the notes, that would mean that we're sort of ignoring all of the functionality that is needed in order for it to work with being saved and loaded and everything. We're kind of ignoring that all of the work that Apple's done to make this work with core data, and we're just saying, I only want to name in the notes. That doesn't help us at all for what we're trying to do, to actually save it in core data. So what we do is we say self.init so that we get all of the functionality that the superclass NSManage object provides, but then we're also able to add sort of our own, little twist on it, like the name and the notes. Initialization is kind of this weird thing because it sort of ends up chaining. It's a little bit complex to follow. Are there any questions about sort of how that ends up working or what we're doing in here?
Yes, I have a question about the initializer.
Okay.
So on line 18, that's a designated initializer, right? And on 16, that's a convenience initializer.
Yes.
So, but how the documentation says that the convenience initializer is a secondary initializer. So shouldn't it be inside a designator, or shouldn't it come after a designated initializer?
No, so I get where you're coming from. It's a little bit weird because we end up sort of calling the convenience initializer, we end up calling the designated initializer in this convenience initializer. But as far as the initialization goes, it's like, because we put this self.init before we are doing our own thing, the designated part of it gets called first, and then the convenience part of it, which is the name in the notes here, gets called after.
Okay, but so line 20 and 21 is the convenience part.
Yeah.
But on line 16, we're saying that whole thing is a convenience initializer, right?
Yeah, the convenience initializer has to call the designated initializer. Without this chain of events never happens, where as soon as we call convenience, it would never call the designated initializer.
Okay, so could you go back to the other screen?
Yeah.
So this convenience on line 16, this convenience initializer is calling it on line 18.
Yes.
It's calling it, okay.
Is calling the designated initializer, yes. Sorry,
Right.
I didn't make that clear.
Yeah, the reason I was getting confused was I was getting confused with hierarchy, where the convenience has to be nested inside the designated.
Right.
Okay, I got it. Thanks.
So they're separate, and then just within the convenience initializer, you call the designated initializer.
Got it.
Okay.
So Spencer.
Yeah.
A convenience initializer works with a designated initializer. It's never like something that you kind of like replace then.
No.
It's not like you don't use it to replace your designated. It just works with the designated.
Exactly, and that's the whole thing. Is it's just literally an initializer to make something more convenient. Like, that's literally why it's called convenience initializer. When you put convenience here, it will yell at you until you put self.init in it and call that designated initializer, because the convenience initializer is just setting up part of things, but not everything. And so that's sort of the whole thing here, is you have to call a designated initializer. Now, what can get a little bit confusing, and I don't want to like sort of confuse you too much, is like here, a convenience initializer can call another convenience initializer as long as one of those convenience initializers somewhere down that chain ends up calling the designated initializer. No matter what, the designated initializer has to get called sometime. So whether it's directly through a convenience initializer, through a convenience initializer that calls another convenience initializer, it doesn't matter as long as that sort of base functionality is set up, and then you can call as many convenience initializers as you want.
Okay, Spencer, just to clarify again, so the designated initializer is initialize the context, which is like the big thing, the general piece, right? And then the convenience initializer initializes more detailed things within the context, right?
Well, it doesn't initialize the context, but it initializes the task that will live inside of the context, sort of like this individual object, right?
Okay. So every single designated initializer, do we go down an additional level, or does it just add another initialization to the context?
Okay, never mind. What's it?
I'm not sure I quite follow what you're asking.
Like in the documentation where you would have 2 or 3 convenience initializers calling the designated initializer. So would those subsequent convenience initializers be an additional object within the context?
No, it ultimately ends up just creating one task. It's just however many steps you need to create that task, whether it's 1 initializer or 10, it'll still just create one task.
Okay, gotcha.
It's just like you writing one function that's maybe 200 lines long and then separating it out into individual smaller functions, but you end up calling them all to fulfill the same purpose as if it was one function.
Oh, okay. So we could actually only have one convenience initializers that's really long, but then just for the sake of us, we separate it.
Yeah, for the sake of convenience, literally.
Got it.
So as an example, if you like, not that you just watch me here, but if you wanted, you could make like a convenience init and just say like, this is like the, test object. And you could literally just pass in a context and just say like, self.init, sorry, again. So I'm going to call task.init. So then we can call this initializer here. That's going to do all of the setup. So we can just say, maybe my test case is like Spencer notes are test notes or something. I don't know. So as an example, like this would be a case where the convenience initializer is just calling another convenience initializer. That ultimately ends up calling the designated initializer, right? So a convenience initializer can do whatever you want it to. It's completely up to you. You can have as many or as little as you want. But that would be an example of this sort of chain of convenience initializer calling another one that ends up calling the designated initializer. So, okay, let's move on. We need to kind of get going here. So now that we have this, now we can go ahead and create our model controller, and this will be really, really quite fast. So let's go ahead and create a new Swift file and just call it task controller. And we'll create a class called task controller. Has anyone talked to you about the acronym called CRUD before? Yes, no? No? Okay. Getting a couple yeses. So CRUD is this easy acronym to think of. It's used sort of all throughout programming, not just iOS development. But what it ultimately means is it's an acronym for create, read, update, and delete. So it's sort of like, you could think of it as the base functionality of really any model controller. In a general sense, sometimes you don't have them all, sometimes you have them all plus some stuff. But in a sense, that's sort of an easy way of sort of coming up with, what your model controller should have inside of it. So as an example for a create, we could say, let's make a create task with name and notes. And let's also create a context. Let's import core data though. And my Xcode crashed. Awesome. Hopefully I didn't lose too much. Cool, I lost nothing. Great. All right, so for this, I'm simply going to create a task here. So let's say let task equal task and just pass in our name and notes and our context. But what I also want to do is I want to save this to core data. So sort of my thinking here is like, as soon as they hit the save button on here, I just immediately want to throw those changes right into core data. There's not really a point for me in waiting. There could be, but in this case, I think it's fine to just immediately save things. So what I want to do is let's go ahead and create a function that's going to do that for us. So let's jump up to the core data stack again, and we're going to make a function here. And once you have this function, this would be a good time for you to, well, we're not going to touch this again, so you can make a code snippet of this like in the afternoon. So I'm just going to call this save to persistent store. And all we have to do in order to actually save this is tell the context like, hey, you know, maybe each of these really bad circles, because I'm drawing with my right hand, represents an individual task. So we've got like 3 tasks that we created. When we say, hey, context, go ahead and save those, that's what ultimately says, persistent store coordinator, I've got some changes, go ahead and throw those down, and that's what throws them into the persistent store to sort of save those 3 objects here. It's that simple, and it's a single method call. So it is, in fact, a throwing method, though. So what we're going to do is we're going to say do. We'll make a catch closure as well. And we'll say try main context dot save. And if there is some sort of problem, we'll just log that there was a problem. So I'll say error saving context. It would be super rare that there would actually be something wrong, that it would actually not work. But in the case that it is, it could be that something about the context is weird and not quite right. So the configuration could be wrong. You may have just messed with it a little bit. I've never actually seen this like in the wild, but what you could do is you could say main context dot reset, and what it does, like it says here, it returns it to its sort of base state. So it just kind of clears everything out and should sort of reset it to a state where there shouldn't be any changes or anything that would make it go wrong again. So that's also a good thing to do if there is an error with saving the context. Okay, so once you've got this, then we can go back, and all we need to do in order to actually save this task is we're going to say core data stack share, access that shared instance there, call save to persistent store. And just like that, that would then transfer this down. Now here's a key thing about an NS managed object context that isn't really crucial for us to think about now, but we'll be talking about it later in the week, which is when you call context.save, regardless of if there is one task in the context or a million, it will save them all at once. And so there's no sort of picking and choosing between, when you say save.context, it just throws everything in there. There's no way that you can say just save this one object. As far as in a single context goes, we'll talk about kind of how to do that later in the week. But ultimately, you just kind of need to know when you say save, it's a blanket statement, and it just saves everything that exists on the context, which generally is actually a good thing. So we can actually see here, like it's yelling at us because our task is never used. This is actually fairly common with core data because you end up not really using the objects after you create them. Just by way of you in that initializer, oh, whoops, right here. Why is this yelling at me? Okay. Just by way of you saying self.init with a context and calling that designated initializer, that's what ultimately puts it in this context. So it already exists there, and we've already set it up, and so there's not really anything we need to do. So you end up just sort of sitting here with these warnings that don't actually mean that you are doing something wrong. So what I want to do is jump back to the task plus convenience. You don't have to do this, but I think it's nice. Before the convenience init, either on the line above or right before it, we're going to do at discardable result. And what this says is, hey, I know that I may not be using this, this task object, and that's okay. Don't yell at me if I don't use it. Just basically saying, like, I know better. And so now what we can do is, it's still going to yell at us, but what we can actually do is delete this whole let task equal and just make it so that it does this. Just call the initializer directly. We don't even have to create a constant for it, but it will still ultimately put it in that context. So this is nice. It's not something you absolutely need to do, but I think it cleans up your code quite a bit, and it makes it so that we don't have any warnings as well. Okay, oh, sorry, I'm just getting a chat here. Okay, so we're going to, I'm gonna skip the read because we're not actually going to put that in here today. Let's go ahead and make the update, and this is quite simple as well. We're just gonna say update task. So just say task with name and notes. We're not going to change its context, so there's no reason for us to include that. But the only things that the user is able to update are just the name here and the notes. And all we have to say is just task.name equals name and task.notes equals notes. So then the question is, how do we then save those changes to core data? What do you guys think?
Running the same thing, core data stack.shared.save to persistent store.
Yeah. The cool part is that save to persistent store is good for basically any changes, including deleting, actually. So for example, like I've got like 3 things down here. Maybe I fetch those up, and so those 3 things exist right here as well. But maybe if I delete one of these, what happens is when I call save to persistent store, the database is sort of the persistent store down here is going to notice, oh, hey, now there's only 2 things in here. I need to get rid of that thing down here as well. And so it deletes it down here as well, or updates it, right? But just so that they both always match up. So all we're going to do is, again, call our core data stack shared save to persistent store. Okay, can you give me a 1 to 3 on how you're feeling overall? And can you also just feel free to ask questions if you have any right now.
On line 19, my context:context.
Yeah.
Second context is throwing an error saying I can't convert value of type NS-managed object context to expected argument type. And then there's like triangles and an arrow. Not sure why it's doing that.
Is your context right here an NS-managed object context? Is it just an NS-managed object?
It's a NS-managed object context.
Okay, so if you go back to your initializer, is this also an NS-managed object context here?
Yes.
All right, just keep following along, and then I'll take a look at it right before we are like able to run the project and everything. Is that okay?
Yeah, that's fine.
It's not going to affect anything that we're going to do here other than you won't be able to build, but that's okay. All right, guys, so let's build out our view controllers now, and this will be pretty dang quick. We are going to go a couple minutes over, and I apologize, but I'll be as quick as I can without like just blowing through this. So we're going to make a Cocoa Touch file that is a subclass of UI table view controller. So we're just going to do that first table view controller here. So we're just going to call this tasks table view controller. All right, so I'm just going to clean this up a little bit. You don't have to do this. I'm just going to get rid of all the functions we don't need. So I'm going to get rid of the number of sections in table view. Go ahead and actually uncomment the self-row index path because we will need that. And then I'm going to get rid of everything else except for the prepare for segue. So we're just left with the view to load, number of rows and sections, self-row index path, and prepare for segue. And in fact, we actually don't need the view to load at all. So let's talk about now, we've got like the saving part essentially done in our model controller. We haven't called those functions, but we will in the detail view. But let's talk about how we actually pull things out of core data. So going back to this really crappy drawing, we sort of said that this was the part that we needed to do, which was sort of like making the request that order to the server of a restaurant. So what we're going to do is I'm going to, let's go ahead and make a variable called tasks. It's going to be an array of task objects. This is going to be a computed property here. I'm going to Slack you all a code snippet that I would love you to, or rather, well, it's a comment, but I want you to all paste this in your code above this variable because it's, you need to know this. So this comment basically just says, hey, this isn't a good way of doing this. We're going to like do a better way even tomorrow. This is just a way to perform a fetch request, and I'll talk about why it's bad. But just make sure that you put that in here so as you reference this code later, you know this isn't a good way to do things, always. It just happens to be very straightforward for what we're trying to do today. Okay, so what we're going to do is we're going to create that fetch request. So it's literally us asking for some things from core data, and we can kind of specify what it is, and we'll get into how to later or how to further specify it later this week. So I'm going to say let fetch request equal, or sorry, we need to actually set its type because I still don't think they've quite made it so that it infers the type right. So we're going to say this is an NS fetch request, and I just realized we need to import core data again. And then we're going to use the brackets that we looked at a little bit last week with associated values and the result type. This is using generics, and again, I know we haven't talked about generics too much yet, but this is really the only line that you need to use it on. Actually, there's one tomorrow. But. So what we're saying here is we're creating an NS fetch request specifically that's going to fetch tasks, like it's just for that. So again, if we had multiple entities, like task and person, this would only be fetching tasks. And what we do is we, again, have to go through our little window into the only thing that we can really access directly, which is our manage object context. So what we're going to do is we're going to ask the context to perform that fetch request. So I'm going to say, just for ease of use, and also it's going to be nice for later, like tomorrow, is I'm just going to say let mock equal core data stack shared main context, just so we can have easy access to that. And then the function that we want to call is this mock.fetch. So we're going to pass it a fetch request, and it's a throwing method. But what it's going to do is return us whatever the type this NS fetch request result is, which is in our case tasks. So it's going to return an array of task objects here, which is awesome because you don't have to cast it like you used to. So we're going to say mock.fetch request, and then I'm just going to put a do try catch around that. We say try mock.fetch. And then we'll just return that array directly. We don't need to do anything. Well, actually, let's do this just for fun, just so we can see what they are. So if we option click on tasks here, it's just an array of task objects. And on this catch, I'm just going to say error fetching tasks, and we'll interpolate that error there. And it wants us to return something. So if it's unable to perform that fetch request, what I'm going to do is just return an empty array because I wasn't able to actually fetch anything for the persistent store. So what we're doing here is we set up the fetch request. We say which context we want to fetch this on, which we only have a single context here. We say, hey, go grab that data, go grab those tasks. And so it goes down, gives the request to the coordinator says, hey, go give me all of these tasks. And then that ultimately gets funneled back up to here in the context where we can access them. We just make a variable to store those. So let's talk about why this isn't a good thing. And in order to do that, let's fill out the table view methods here. So now we can just use that tasks array as our data source. So we can just return tasks.count. For our cell, it's going to be called task cell since we have the storyboard, it's already made for us. And all we're going to do is just say cell.textLabel.text equals our tasks index path, index path dot row dot name. Excuse me. Actually, I think I'll wait till we run this in order to show why this is a bad way of doing it. We kind of actually talked about it with stored properties and computed properties, but. All right, so we need to fill out the prepare for segue. In order to sort of do that fully, we actually need our detail view controller first. So we have a place to pass our task and our task controller over. So we haven't actually made the task controller yet, but let's go ahead and make a new Cocoa Touch file. And this is going to be just a subclass of UI view controller. And we're going to just call this task detail view controller. Okay. So we'll make a variable for our task controller and a potential task that's also getting passed over. So we're just going to say task controller is of type task controller optional, and same thing with var task. So once you've got that, we can go ahead and jump back to our prepare for segue and sort of fill that whole thing out now. And it's relatively straightforward. Although I think, well, here, let's do this first one. We might have to go to the storyboard and add another identifier. I can't remember if there's already one made. I don't think there is. So we're going to say if our segue identifier is show task detail, that would be if we tap on the cell of an existing task. So we'll say if let detail vc equals our segue.destination. as that task detail view controller. And then we also need to ask the table view for the index path that, oops, that was just tapped on. So we're going to say table view dot index path for selected row. And if there is one, then we know that we're basically performing the right segue here. So we can say detail vc dot task equals our tasks index path dot row. And we're also going to pass the task controller, so we actually need to make a variable for that because I just realized we haven't done that yet. So even if you don't have this, just jump up to the top of the file with me. I'm going to come right back to this. So right above like the var task, I'm just going to say var task controller equals task controller, and we'll just initialize a new one here. So then jumping back down here, we can say detail vc dot task controller equals that task controller that we just made. Okay, space that out so you can see a little better. Let's all jump to the storyboard because I think we need to make a segue here real quick. Yeah, we do. Oh shoot, this doesn't even have that identifier. Okay, so click on that segue that already exists here. Just go ahead and click on the arrow, and we'll give this identifier show task detail. And then, sorry, I did that really quick. And then we just need to make another segue from this plus button here, this bar button item. We'll just make it a show segue. And I'll just say show create task. Okay, so I'm going to jump back now, and right at the end of this if statement here, we're just going to put else if segue dot identifier equals at show create task that we just made. Then I'm going to say if let detail vc equals our segue dot destination again as our task detail view controller. Then all we need to pass this time is just the task controller so that it can create a new task if there is one. So we'll just say task controller. Sorry, we can create a new task if they actually hit the save button. Otherwise, when they hit the save button, it won't do anything. Okay, the last thing we need to do before I forget is in order to actually have these show up, like if I change this to like hello world, actually have the change show up over here, we need to reload the table view when we come back here to this table view controller. So I'm just going to call the view will appear function and call the super view will appear. And then we can just say table view reload data just so that it actually updates the cell, actually shows that something happened instead of something happening behind the scenes, but not really actually showing or reflecting that change to the user on the view itself. All right, we've got like 2 more functions and then we're done. So let's go to our detail view controller here. And all we need to do on here is open up the assistant editor, and we'll need to just add some outlets and an action from the save button. So I'm just going to go to, oh, you know what? Sorry, we need to set the class here to be our task detail view controller. Actually, oh shoot, okay. While the assistant editor is open, go ahead and set the class of that table view controller first. That's also not set. So let's set that to be tasks table view controller. Okay, and then from there you can then make an outlet from the name text field, which is exactly what I'll call it, and then the notes text view. And then I'll just make an action from the save button and just call it save. Okay, so once you've got that, let's go ahead and fill this out. And we also need to make an update views function. So let's do that real quick, and then we can end on the save function here. So I'm just going to make a func update views. Then we'll just say, I'm going to make sure the view is loaded. Else we'll just return out of the function. And then otherwise, we can say our title of our view controller is, like, we'll just do our task.name. Or if there is no task, then we'll just do create task. And then the name text field .text is going to be our task.name if there is one. Otherwise, it'll just be an empty string. That's fine. Or it'll stay just whatever it was. And we'll change the notes text view to be the same thing, just with the notes. So let's just call this in the update views for now, and then maybe later we can have a broader discussion on why I'm just calling it in the update views and not in the task, but this will work fine for what we're doing. So ultimately what we want to do in order to sort of round out the functionality of this is grab the text from the text views. What I mean by that is like views, like text field, text view. Either save or update the existing task. Sorry, I'm going to say either save a new task or update the existing task. So let's grab the text first. So I'm just going to say if let name equals our name text field dot text, then comma, and then we'll do notes equals our notes text view dot text. Then all we have to do is use the task controller because we've already made functions to create and update tasks. So how could we know which one we want to do, whether we want to create a new task or update one that already exists?
Check if task is already set or not.
Yeah, if we have a task here, that means that we tapped on this cell and we've actually passed over the task from the segue. If not, then we're probably just tapping on this add button, assuming everything is working right. So let's just say if let task equal task, then we can say there is a task. Let's call task controller dot update our task with the name and our notes. And then we can just make an else statement and say, well, otherwise we can call the task controller.createTask with name nodes. And then for the context, we'll just do core data stack.shared.main context. And then finally, at the very end, we'll just call navigation controller.popViewController and have it kick us back to the table view controller. All right, once you've got that, go ahead and run it. Jerry, let's take a look at your project while everyone's running it. But at this point, it should be completely functional, in theory.
I'm actually like really behind. I had to restart my Xcode. So just take a look at the one that you post in the the Stack channel.
Okay. So let's just run this here and see if we've got it working. Let's say test iOS10 load. Okay, so I can go ahead and kill the app, run it again, have it pull up.
Hey Spencer, am I missing something in the app delegate?
No, you shouldn't need anything in the app delegate.
Okay, because I'm getting a terminating with uncaught.
Oh, cool. Awesome. That's great. What does it say? This might actually be illustrating what I was talking about with lazy.
It says terminating app due to uncaught exception, NS internalized, inconsistency exception, reason unable to dequeue a cell with identifier.
Oh, dang it. Okay. So just make sure your identifier is task cell like that. Otherwise, you might just make sure that it matches whatever you have in the storyboard.
Yeah, I totally forgot that. Thank you.
Yeah, you're welcome. Let me see if I make this unlazy, if it crashes the app, because that'd be cool. Okay, well, it didn't crash. And that's the problem, is sometimes it's gonna have enough time. It's probably dependent on how much information you have in the persistent store. But if you make it not lazy, this var container, sometimes it's just not able to set everything up in quickly enough. So we just put lazy there in order to let the rest of the app load until some time that we call container, and that amount of time gives you enough to make sure that it's able to load everything up correctly. Yeah, so that's everything I've got. More than happy to stick around if anyone has any questions. I will definitely send the finished project, so if anyone needs that, they can take a look. But if not, then you are more than welcome to head out. And you're going to be making a similar project to today. It actually is a journaling app, so yeah, just let us know if you need any help, and you're more than welcome to go to lunch. So thank you guys so much. Does anyone have any questions that they want to talk about before we jump out?
Yeah. Am I able to, can you just go through each of those screens so I could take a screenshot, because I think I missed some code?
I'll just send you the solution project if that's okay. Does that work?
Yeah, sure. No problem.
All right, guys. Thanks so much. I'll talk to you later.